Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we'll discuss the last chapter of System Analysis and Design 2, in fact chapter number 18, but we had skipped it at that time. So today we will discuss Object-Oriented Design and Modeling. So we'll talk about different type of classes from the design perspective. We'll talk about different relationships of the classes. We'll particularly talk about dependency and navigability. We'll discuss different type of visibility of the methods and the attributes in the classes. We'll talk about object responsibility and how it is used to pass messages between the different objects. We'll talk about different activities involved in object-oriented design, the steps that are used to design the systems by using object-oriented technique. Next, we'll talk about the three diagrams that we have discussed in SAD1. Now we'll talk about them from design perspective. So you have learned how to develop a use case diagram and how to develop use case narratives. So now in SAD1 it was from analysis perspective. So now we'll see how to convert those use case narratives into design use case narratives. We'll talk about CRC, a technique used for determining object responsibility. We'll discuss sequence diagram again. In SAD1 it was from analysis perspective. Now we'll talk about it from the design perspective. Also the class diagram. Now we'll talk about the design class diagram, and finally we'll discuss the different object states and the state machine diagram that is used to model these object states. So object-oriented design is an approach used to specify the software solution in terms of collaborating objects, their attributes and methods. So it was the same thing in SAD1, but that was from the analysis perspective. So now we'll see how the objects, attributes, methods, they can be designed to propose a design of the system. Well, you know that in every object-oriented programming environment, every piece of code resides inside the object classes. We cannot have any piece of code, even one line of code, outside the class. So classes are the heart of the system or the heart of the design in the object-oriented programming. So classes are the core. Everything resides inside the class, whether it is the data or the user interface or the algorithm, the control. Every functionality is inside the classes. There are different types of design classes. We'll try to understand them before we move forward. First of all, entity class contains business-related information. So these classes, they contain the information for different entities, as we also have entities in the database. So it is kind of similar concept. These classes contain the information related to different entities in the system. Next, interface class. Every system has many interface components, and all these components are defined inside the interface classes, like windows, dialog boxes, buttons, checkboxes, radio buttons, and so on and so forth. So all user interface components and the system interface components in the form of APIs, all of these, they are referred to as interface classes. They implement the interface of the system. Next is the control class. This is the core class, the most important class, which connects everything together. It contains the application logic, the algorithm, the workflow, the policy, the business logic. It resides inside the control class, and as the name implies, it also kind of controls all the other classes. So a control class is used to connect all the entity, interface, and if we have persistence, persistent and system classes, it is used to connect all of them together. So essentially, any system can be developed with these three classes: entity class, interface, and control class. They can be used to implement any system. But we have two extra classes, optional classes, that can be used to uh, make the system more reusable. Okay, the classes can be made more reusable if we use these two classes. First is persistence class. It provides functionality to read and write to the database. So we can put this functionality inside the entity class as well. We can put this functionality in the entity class to read and write the information to the database. But if we want to separate the data from the implementation or the storage and retrieval, then we can have persistence classes to implement this functionality. It is an optional class, as I said before, so you can put this functionality inside the entity class as well. But to make it more reusable, we can also have persistent class. Similarly, system class is also optional. It handles operating system specific functionality. So let's say today we want to develop a web-based system, okay, and or you make a system for, let's say, Linux environment or Windows environment, and tomorrow you want to port it to, let's say, Android or iOS platform, then you do not need to change all the system. You can just change the operating system or platform specific functionality which is there in the system classes, right? So if we plan to make the system portable, if it can be ported to other environments, if we have certain operating system specific functionality, we can put it in system class. So in one system, you may not need any system class. In another, you may need it. So as I said before that, the last two classes are optional, persistence and system class. Right? The next thing is the relationships in the system design. We'll talk about two kind of relationships, dependency and navigability. Dependency, as the name implies, is used to model the association between two classes to indicate when a change occurs in one class, it may affect the other class. So it depends, one class depends on the other class. So if it changes, it will trigger a change in another class. Or to indicate the association between a persistent class and a transient class. So we have two kinds of classes. Persistent classes, these are the classes which remain kind of alive even the application has exited. Like the permanently stored data in a system. A class which is reading the data in a database, right? Now this data will be stored in the database, and even if you exit the system, it will still remain there in the database. It is persistent. However, a user interface class is a transient class. When you close the system, this class will stop existing. It does not exist when you close the system, right? So user interface classes are transient classes. The classes which are related with read and write operations, which are writing the data in the database, they are persistent classes, right? So illustrated with dashed arrow, like here, this class depends on this class. So we have modeled it as a dashed relationship. A change in this will have some impact on this class. When a user has ordered some products from the order display window, this information will be put in the new order, right? So it has some dependency. This class depends on this class. Next is navigability. Classes with association can navigate to each other, which means they can send messages to each other, right? So all the classes, they can send messages to each other through methods, right? So this association is represented as navigability. By default, the associations are bidirectional. It means this class can pass messages to this, and this class can pass messages to this. This is the default behavior. However, sometimes you want to limit the message sending to only one direction. It is illustrated with arrow pointing in the direction a message can be sent. Like here we are saying that a message can be sent from user to the password class, not the other way around. A password class cannot send a message back to the user class, but a user passes to this set password class. Okay, so the scenario over here is that a user calls change password method with the user ID, and then up to 6 previous passwords are passed. It means the user cannot pick any password from the last 6 passwords, so it will pass on 6 passwords to this class, but the password class cannot call the user class. It means it makes sense, like we should not say like to which user this password belongs, right? So it doesn't make any sense. So by default, all the classes can pass messages between each other, but sometimes we just want to limit message passing in one direction, so we can specify it with these arrows. The next thing is attribute and method visibility. I'm sure all of you have studied in the Java or any other programming language course that we can declare both the attributes and the methods as public, protected, or private. Public means these attributes or the methods can be accessed by any other method in any other object or class, right? So mostly the getters and setters, they are declared as the public methods. Any object from any other class, they can call this class to get the data or to set the data in the class. Of course, we have many other methods as well, but here we have just 2 methods like street and city, and any other object can get the value of street and city from this class through these methods, which are declared as public, right? And mostly the data members are declared as private. Okay, it means they cannot be accessed. So private attributes or methods cannot be accessed by any method they cannot be accessed by any methods outside the class, so they can be accessed only by the method inside the same class, right? So public, which can be accessed by any method outside the class; private, which the attributes or the methods which can be accessed by only the methods inside the same class. They cannot be accessed from outside the class. Protected is something in between them. So these attributes or methods can be accessed or invoked by any method in the same class or in subclass of that class. So sometimes we want to limit the access to the classes inherited from that class, so we can declare them as protected methods or attributes. The next thing is object responsibility, the obligation that an object has to provide a service when requested and thus collaborate with other objects to satisfy the request if required. So every object has certain responsibility. If we have declared its methods or the data members are always declared private, if those are declared private, then it needs to collaborate with other classes to provide the information, to set the information, or to provide any other services to the object. So this is called object responsibility. For example, here we have a scenario for placing order for the user. So first of all, the user sees an interface and a message is sent to request the display of a customer order information. Now for customer order information, first we need customer information, and second we need the product information, right? The products that have been ordered by the customer. So now this object, it needs to collaborate with two other objects, the customer object and member ordered products object, to get the customer information. So it sends a message to get customer information. So now the responsibility of this customer object is to return the customer information. It is its responsibility. Similarly, member order product class or object, it doesn't have this information, so it calls the product object to get the product detailed information, and then it passes it back to the order object, and now it can display the customer order containing the customer information and all the products that have been ordered in this ordered by the customer, right? So this is the responsibility. Every object needs to collaborate with other objects to provide certain information or to fulfill their requests. Now coming to the process of object-oriented design, it's a very simplified process. Of course, we will study it in much more detail if you take the object-oriented analysis and design course. So we refine the use case model to reflect implementation environment. As we have discussed several times in this course, that design is all about the implementation details. Just like when we talked about the data flow diagrams, the logical data flow diagrams do not have the implementation details. The physical DFDs, which are a part of the design of the system, they also have the implementation details. So now same applies over here. For the use case model, we refine it to include the implementation environment. Second, we need to model the class interaction, behavior, and states that support the use case scenario. We'll see inshallah some techniques for this. And the next is update the class diagram again to reflect the implementation environment, right? We'll see quickly, not in much detail, but we'll see shortly how to convert all the logical diagrams, the use case, sequence, and class diagrams into physical or design diagrams. So first of all, the use case model. First step is to transform the analysis use case to design use case. How? We need to add the implementation details. We'll see one example inshallah. So we have all detailed information about how the use case will be implemented, different kind of controls, the user interface components, windows, web page names, navigation instructions, how the messages are passing between the different classes, right? In step 2, we update the use case model diagram and other documentation to reflect any new use cases. So if we also discover some missing use cases, we'll also update the use case model with these new use cases. So just to give you a small example how we put the implementation detail, first of all, you can see here that we have ticked this use case type as system design. In SAD1, it was the analysis use case type. And now if you see this scenario, okay, we have given the complete details for this use case. So in step 1, the member clicks on the place new order icon or link. In step 2, the system responds by displaying window W11 catalog display. If the product list is greater than 50, which is maximum number to be displayed on one page, the system calculates on the blah 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 blah. Next, step 3, the member scrolls through the available items by using scroll bar buttons or the page up, page down keys or the navigation controls and so on and so forth. In step 4, once the member has completed making selection, blah blah blah. Step 5. Now you can see that we have given detailed instruction of all the implementation, how it is going to be implemented. So any developer in the next stage has a very clear idea of what kind of classes are there. Inshallah, we'll see in the next step. We'll also extract all the classes from it, what types of classes are there, then we'll see what are the attributes, the navigation, and so on and so forth. So now we have detailed use case scenario in which we give all the complete implementation details for this use case, right? Next, we need to model the class interaction, behavior, and states that support this use case scenarios. So for this phase, first step is to identify and classify use case design classes. So now from this scenario, we can identify different use case design classes. Okay, we'll see shortly. Identify class attributes. We also have class attributes. We have identified them in the analysis phase, but we'll see if something is missing, we'll put them over here. Identify class behavior and responsibility. We'll also see what is the responsibility of every class in the use case. Model object states. This is something new you have not studied in SAD1. We'll see shortly, inshallah. Any object can have different states, and a state machine diagram is used to model these states. And the last step is about modeling the detailed object interactions, right? So let's go through all these steps. First of all, identify and classify use case design classes. So here we identify and classify all the classes, interface, control, and entity classes of place new order use case that we have seen. So these are interface classes: member homepage W00, W02 is member profile display, disorder assembly, and so on and so forth. If I take you back over here, like here we had seen W11, it is one use case class. Here I can see W02, member profile display, and so on and so forth, right? So from there we can identify all the interface classes. We have only one control class, which is place new order handler, and we also identify all the entity classes which contain information about various entities or various objects in the system. So these are all the entity classes taken from the use case shown to you before. Step 2, identify class attributes. So as I said before that most of the attributes are already defined during the analysis phase. Revised use cases may mention additional attributes. Sometimes when you are designing the system, you identify that some things you have missed in the analysis phase, so you can revise them. And the important thing is to update the class diagram also to include these new attributes. It's very important to put all these attributes in the class diagram as well. In the next step, we identify class behavior and responsibility. As we discussed before, that every class or object has certain behavior and certain responsibility to collaborate with the other classes or objects. So we analyze use cases to identify required system behavior. We search for verb phrases. So the responsibilities can be identified by looking for the verbs in the use case. Some will reflect manual actions, others automated. Some verbs they are related to the manual actions, like scrolling through list, clicking a button, clicking an icon, and so on and so forth. These are manual actions. However, some verbs are associated with the behavior of the object, so we should look for them. Associate behaviors and responsibilities with the classes. We also need to associate which behaviors and responsibilities are associated with which class. Model classes that have complex behavior. So if any class has a complex behavior, we need to model it separately. Examine class diagram for additional behavior. We also need to look into the class diagram to see if we have not missed any behavior and verify the classification. We'll see shortly. Like here, we have all these behaviors, condensed behavior list for place new order use case. It is not a complete behavior list, it is a condensed list. The behaviors are process new member order, retrieve product catalog information, display at W11 catalog window display, and so on and so forth. And here we have also classified them as control, entity, interface, or if we also have persistent and system classes, we also put them over here. So this behavior is associated with a class whose type is a control class or entity or interface class, right? Tools for identifying behaviors and responsibilities. We'll talk about two tools. First is CRC. We call it Class Responsibility Collaboration Card, a card that lists all behaviors and responsibilities assigned to a class. So these cards, they list all the behaviors and responsibilities for every object or class. They are often built interactively in a group setting that walks through a use case. So mostly in a group setting. We'll see shortly, inshallah, in the next technique when we talk about it. So in a group setting, the different people kind of have a role-playing scenario in which they assume the role of different objects, and then they have any object like a soft ball that is passed between the members to simulate this message passing. Like here you can see this CRC card for member order. So these are the behaviors and responsibilities for this class, and it needs to collaborate with this class member order product. Sequence diagram is a tool that is used to depict the interaction of messages between the objects in time sequence. We have studied it in SAD1 as well. So all the objects, their activation and the messages that are passed between them through a timeline, all of this information is put in a sequence diagram. We'll see shortly how to convert a logical sequence diagram into a physical sequence diagram. So here, this is a physical sequence diagram, and you can see that there are many differences from a logical sequence diagram. Like here, we have also put the class type. Like this is an interface class, this is a control class, and without anything, these classes, they are the entity classes, right? So we can see the interface, controller, and entity classes. The messages are passed, like here, add item message is passed from the interface to the controller class, and for adding item, this controller needs information from the product class, right? So calculate the quantity in stock from the, it gets this from the product class, it passes back the quantity, and now it needs to add item with product number and quantity ordered. It will calculate the total, it will get the price from this product class, the price is sent back, and finally it loops through this. This box is showing that it loops multiple times through these steps, and at the end, when we have a complete order, this updated order is sent back to the order window, right? So this is how we design sequence diagram will show the sequence of messages and the types of classes or the objects involved in the use case. We'll quickly go through the guidelines for constructing sequence diagram. First of all, we identify the scope of the sequence diagram. It can be for the entire use case scenario, or if it is a complex use case, it can be for one step as well. Draw actor and interface classes if the scope includes that. List use case steps down the left hand side, right? So all the steps they are put in the left hand side. Draw boxes for controller class and each entity class. that must collaborate in sequence based on the attributes or behaviors previously assigned. So we have already identified the responsibility and the behavior of the objects. So now in the sequence diagram, this information is used to show the collaboration of all the objects in the time sequence. Add persistence and system classes if the scope includes add. Draw messages and point each to class that will fulfill the responsibility. Add activation bars to indicate object life instance lifetimes. For example, if you go to the previous diagram, here you see this object is existing till this time, then it is destroyed, and from here it is existing, right? So between this and this time it does not exist, it is not activated, right? Add return messages as needed. So here we have also included like extended price is returned, updated order information is returned, updated order is returned, and finally add frames for loops, optional steps, or alternate steps. Like here we have put this frame for loop to loop through these add item phases, right? So these are the guidelines for developing a sequence diagram. Pretty much same as you have done in the analysis use sequence diagram. Next, in modeling object states, what is an object state? And a condition of the object at one point in its lifetime. Well, in any system we have many objects, and not necessarily every object, but some objects have different states, right? For example, if you are playing a game, then the game can be in the running state, or it can be in a pause state, or when all your chances are gone, it is in a finished state, right? So these are three states. So similarly, in any system, we need to identify all possible states of the objects and the events, state transition events, the occurrence that triggers a change in object state through updating one or more of its attributes values. So what triggers a change of the object from one to the other state? For example, let's say, again talking about the same game object, when you are playing a game and let's say you have 3 chances, when your third chance is gone, it will trigger a change of the game from the running to finished state, right? So we have different events which trigger a change of the state for any object. So they are the attribute values. So whenever this attribute value will change, it will change the state of the object. And the diagram that is used to model these states is called a state machine diagram, which contains a combination of states that an object can have, the events that trigger the transition between these states, and the rules governing the object in transition. Let's show you a small example. Like here, let's say it is a possible states of a space shuttle. So we have a pre-launch state. Okay, this shuttle is ready to be launched, but a takeoff event will trigger a change in the state of the space shuttle into flight state from pre-launch state, right? From an information system perspective, here is a state machine diagram for the order, okay, member order. So member order initial state, okay, this is the initial state. When the order is submitted, it becomes in progress. From in progress, the next state is order rejected. So member order final state. Maybe because of the member's past history, the order is rejected. So now from in progress, it goes to member order final state. It is the rejected one, right? From in progress, it can also change a state to order back ordered. Why? What will trigger this? When all the products ordered by the customer are not available. So this thing, if all the products ordered by the member are not available, it will trigger a change from in progress to back ordered state, from in process state to back ordered state. And when the products are received, they will trigger a change from back ordered to in progress. Similarly, if order may be pending awaiting payment or additional member information, so if this thing happens, then the state of the order will change from in progress to pending state. And when we have received the response from the member, again it will become in progress. To warehouse, it will become in release state, it can be in filled state, order shipped, order invoiced, order closed, and finally it is archived. This is the member order final state, right? So you can see in this example that we have many states of the order object, and we have different rules or the attributes that trigger change from one to the other state. So this state machine diagram, it will capture all possible states and what triggers a change from one to the other state of the object. Next is to verify object behavior and collaboration. As we discussed before, we identify and we need to verify the object behavior and collaboration for all the objects involved in a particular use case. So as I told you before that it is a kind of role playing, the act of simulating object behavior and collaboration by acting out an object behavior and responsibility. So what we do, participants may assume the role of an actor or an object. Okay, we have many objects involved in a use case, so the people will assume the role of all those objects, and then they have like they can have a soft ball that is passed between the members to simulate the message sending, right? So one member will pass the ball to another and say that okay, this message is passed to you. Then he or she will pass it to another member with clearly saying that I did this, or I need this information, or I'll pass this information for you, and so on and so forth, right? So this message sending is simulated by a small soft ball, and ultimately we should have captured the responsibility of all the objects at the end of this activity. It is useful for discovering missing objects and behavior, right? I hope you get the basic idea that for any use case, for all the objects, the different people will assume the role of those objects, and then they will have a ball. It will start from the first object, from the first person. He or she will pass on to the next person, clearly telling what this means, like what message or information is passed or requested. Then the second person will pass on to the third, fourth, and so on and so forth till the entire use case is completed. So we can verify the behavior and responsibility of different objects in the use cases. The last thing we discussed is the class diagram. So we update the class diagram to reflect the implementation environment. So now the analysis class diagram is taken to put all the implementation details to convert it into a design class diagram. So a design class diagram is a diagram that depicts classes that correspond to software components that are used to build software application. What it includes? It includes the classes, just like in analysis use case, association and generalization, specification or aggregation relationships you have also studied in SAD1. Attributes and attributes type information you have also studied in SAD1. Methods with parameters, okay. Navigability, dependency, and we have not put it here, but also the public, private, the access type of all the methods and the variables in the class, right? So we add, this is a detailed process for transforming the analysis class diagram to design class diagram. So we add design objects to the diagram, we add attribute and attribute types, all the attributes, and whether they are integer, float, character, string, or whatever. Add attribute visibility, okay, whether they are public, private, or protected. Add methods to the design objects and add method visibility, this is new thing, whether they are public, private, or protected. Add association navigability and the dependency relationship between the classes. So this way you can see that these things, they are common in the analysis and design diagrams. The visibility is new thing, the navigability is a new thing, and the dependency relationship is a new thing that we do not have in analysis class diagrams. There are 4 implicit behaviors of every class. We need to be very careful. We should not miss them in every class. So every class must have methods or a behavior to be able to create new instances. It should provide a way to update the data or attributes, to delete the instances, and to display the information. If you recall, we have studied in the data flow diagrams also what we call CRUD: create, read, update, and delete. So for every data item in the data flow diagrams, or for every class in the class diagram, we need to have these 4 behaviors. They are must for every class. We should be able to create the new instances, we should be able to read the information, update, and delete the instances, right? So it is just to show you a small example. We have a partial design class diagram, and just to show you the difference, you can see like this is the actor, okay, active member, and here you can see minus minus minus. It means all these attributes are private. With the methods, you can see plus. It means they are public methods. It is a persistent class, okay. It places member order, okay. We have one member can place 0 or more order. It is also a persistent class. This is, here you can see controller, it is a persistent class. Here you can see boundary, it is a Windows interface class. It is transitory class, okay. If you remember, we have discussed it in the earlier slide. These are persistent and these are transient classes, and this is the relationship, okay. This boundary is used by the controller. This order summary display is also used by the order place new order handler, okay. This is product class, okay, and so on and so forth, right? So you can see that in design class, first thing, we also have the class types, okay, whether they are boundary, they are controller, or they are actor classes, okay, whether they are transient or persistent classes, what kind of relationship they have, and navigability, how many messages can be passed between them, and the visibility, whether the attributes and the methods, they are public, private, or protected, right? So with that, we have completed the object-oriented design chapter, and we have also completed the entire course of system analysis and design 2. Thank you very much.